Good day guys, welcome to today's video. In today's video we are talking about transistor and MOSFET. So this two thing is under FET family, which is transistor and MOSFET. So we have three basic things that we are going to discuss in this video. One is how to identify a transistor, whether if it is PNP or NPN. Then secondly is how to check the transistor to know the one that is emitter, collector and base. Then thirdly is about MOSFET, how to check the condition of MOSFET using N-channel MOSFET. So we are using N-channel MOSFET in this video because it is the most popular and common MOSFET we see in electronics today. So without wasting much of your time, let's go into the tutorial. So first, let's assume, first I will show you the equivalent circuit of a transistor and how to know the one that is PNP and NPN without using a data sheet. So what if you come across any transistor that you don't know the data sheet, but you want to identify if that transistor is a PNP or NPN? How do you do that? I'm going to show you that in this video using a multimeter. So first of all, let's go to the theory aspect before we go into the practical aspect. So in order to do that, this is the equivalent circuit of a transistor. Okay, so once you bring any transistor, all you need to do is just to draw this equivalent circuit if you have the time to draw that. But I'm drawing this in just to show you how to check it. So looking at this equivalent circuit, it is made up of a diode. And we know that a diode only allows current in one direction and block current in the other direction. So that is the equivalent circuit of this transistor. So using this one as an example, let me show you how to check it using a multimeter. If you watch, this is the anode side, while this is the cathode side. And you know, if we are passing current through this side, current can only flow through here and outside here. But if you are trying to put a current through this side, you will notice that this diode will block that current, especially if you put current here, this diode will be in forward bias. And if you change your polarity and put the plus here, put the negative here, this diode will be in negative bias. So that's what I'm going to do now. So let me show you how to do that in order to identify which one is a PNP and which one is NPN. So in order to do that, all you need to do, I'm going to show you the example before I can bring the actual transistor. So what you're going to do, I'm using a auto range multimeter. So I need to set this multimeter in so like I said that we are going to put our multimeter in continuous mode. Here I'm using an auto range multimeter. So if you are using the other multimeter, just put the die in the continuous mode and let's check. So I'm going to do it like this. First of all, use the red probe, put here, and use the black probe, put here. You should have a forward bias. You should have a reading in the multimeter, and also use this black meter to put the other side. You should also have a reading in the multimeter. So once you have a reading this side and this side, why this red probe is being here, that means is an NPN transistor, because let's assume putting this thing like this is putting this diode in a forward bias. Looking at, let's say that this is a negative probe, while this red one is a positive current. Let's use this color coding to do the illustration. So here I'm applying a positive voltage, which is because this red is a positive current, while this one is a negative current. So putting it here and here shows that this diode, we are putting this diode in a forward bias, so we'll get a contour in it. Then putting this probe here will also give us a reading, because we are also putting this diode in a forward bias. So this is an NPN transistor. NPN transistor. So if we turn this thing around and put this black here and put this red here, you will see that we will have a reverse bias, because this diode is in a reverse bias condition, because we are putting the positive, we just change the polarity of the current, so it will put this diode in a reverse condition, in a reverse bias condition. So you won't see any reading in the multimeter. Likewise, if we put here, so once you check it and you do not get any reading, all you need to do is to interchange your probe. Once you get reading here and here, you will know that it is NPN. Look at what I meant here. This P, this, if you watch here, you see that this is the base. So the base must be common to the two terminal, to the collector and to the emitter. So the base must be common. All you need to know, even though I will also show you how to identify the pins, the one that is collector, base, and emitter. I will show you that. That will be the second step. So this one is a NPN transistor. So let's go to the PNP transistor. So how do we do that? Likewise, the same thing. If you look at the arrangement of this diode, you will see that if we put the red probe here and put the black probe here, we are also putting this in a reverse condition, reverse bias condition. Likewise, if we put it here, so if you put it, you will not get any reading from the multimeter. All you need to do is to interchange the probe and put the probe in the base, which will serve as the common to the two terminal. Then if we put the red probe here, you will get a reading, because this diode is put in a forward bias condition. And likewise this one. So once you get a reading like this, the black probe being in the base, and you get a reading between the two terminals, you will know that it is NPN transistor. So before I will show you the practical aspect, let's also talk about let me show you what I mean. So looking at this circuit here, this is three different transistor. Assuming I don't know let me show you the part number. I'm using a BC. Let me show you the part number. Looking at it, sorry for that. This is BC557. This one is 2N222A. This one is BC547. So that is their part number. Assuming I don't know so let's assume I don't know which one is PNP and which one is NPN. So let's identify that. All these transistors, I don't know which one is PNP and which one is the NPN. So let's identify that. All you need to do, just use your probe and put in the middle of the leg of the transistor. I'm starting with this one. So first of all, let's check if our multimeter is reading to continue it. So it's doing that. Use the red probe, put in the middle. I don't know if the middle is the base or if it is the collector. I don't know. What I'm going to do is just to be checking it one by one after the other. I'll put the red probe in the middle and use the black probe to check this one. As you can see, I'm not getting any reading. Putting it the other side, I'm not getting any reading. So let me interchange the probe. So like I said, we are going to change the probe. So I'll put the black probe in the center Before, what I did was I put the red probe. I put the red probe in the center and check it like this. I'm sorry for that. The multimeter must be in the diode mode. In the diode mode. So if you check it, you will not see any reading. So what I'll do is to interchange the probe. Then the negative probe will be in the center. Then while I use the red probe to test. Looking at our multimeter is showing reading. It's showing reading. So this here, the center one is the base. So this center one is the base. And this is what do we call this one? This one is PNP. PNP. This two leg is P. This two leg is positive. While the center one, which is the base, is the negative. That is why it is called PNP. This transistor is a PNP transistor. Okay, because I'm using the black probe to put in the base, which is the common, and I'm getting reading in the both leg. So this is PNP. So let's check this one. I'm going to put the center probe here. Then no reading. Then I will interchange the probe. I'm getting a reading. So this is NPN. This one is PNP. This one is NPN. Just watch the position of this probe. This red one is in the center, while I'm using the black one to test. Okay, I'm getting a reading. So this is NPN, while this one is PNP. Let's check this one. I'm getting a reading. Let me interchange it. No reading. So this one is NPN, because I'm getting a reading using this red probe in the center. So this is NPN, PNP. Okay, that is for the first session. So the second session is how to identify the one that is base, the collector, and the emitter. So in order to do that, in order to identify the one that is emitter, collector, and base without using the data sheet, all you need to do is to put your probe in the base. Since we have identified that the center legs of this three transistor is the base, all you need to do is to put your probe in the base. Then check the reading between these two legs. The higher one is the emitter. What do I mean by that? Looking at this one, this is NPN, so the base will be the red probe will be in the base. So looking at this reading, what are we getting in this reading? We are getting 0.705. This one is 0.700, which is this one is the emitter, because the emitter reading must be higher than the collector reading. So the higher one shows that it is the emitter, while the lower one shows that it is collector, being that your red probe is in the base. Okay, so let's try that again. 0.705, 0.700. So this terminal, this pin here, is the collector. This one is the emitter, while the center one is the base. So let's try that using this 2N222A transistor. This one is BC547, while this one is 2N222 transistor. So let me identify. So the center one is the base. So let's identify the collector and the emitter. So let's try that. We are getting, we have we have 0.707. okay, here we have 0.708. normally 0.707, this one is 0.706. This one is 0.707. So this one is the emitter, while this one is the collector. So this one is the emitter, the center one is the base, this one is the collector. Meanwhile, this transistor, this side is the collector, this one is the base, this one is the emitter. While this one is the collector, base, emitter. So you can check that using your data sheet if you want to confirm what I'm teaching here is true. So this one is 2N222 transistor, while this one is BC547 transistor. So let's go over to BC557, which is the PNP transistor. So in order to do that, just the same method goes for this one. So since this one is a PNP, we are going to use the negative probe in the base. So let's take the reading. So I'm having 0.718. The other one is 0.714. So this one is the emitter, this one is the collector. So that's how to identify the pin out, the pin name. I've shown you how to check how to identify the PNP and NPN, and also how to identify which pin is base, collector, and emitter. So let's go over to the MOSFET aspect. So moving on, this is the MOSFET. We are using N-channel MOSFET because it is the most popular and most widely used MOSFET in electronics today. So this is the symbol. I will show you how to check if the MOSFET is in a good condition or in a bad condition. How do we do that? Using the same diode mode. Okay, all we need to do before we check that, we make sure that we discharge the stored charges in the gate, because if you look at these two symbols, this is a symbol of a capacitance, a symbol of a capacitor. Once we apply voltage to the gate, the little charges that is stored here allows the higher current that will flow from drain to source. Okay, so before we test that, to get the exact reading, we need to discharge it using our 3 finger to shorten the 3 pins. Okay, so that we can be able to discharge it from gate to source. So in order to check if this MOSFET is in a good condition, all we need to do is to use the same method. Okay, just we put it in a diode reading. We put, this is the drain, this is the source. Okay, then we put our red probe here in the source and put our black probe in the drain. If we get any reading, what we need in order to do that, you just put your red probe in the source, put your black probe in the drain. If we get any reading, then we interchange the probe, then put the red probe in the drain and put the black probe in the source. So if we also get a reading, that means the MOSFET is bad. But if we not get a reading, that means the MOSFET is good. Let me show you what I mean by that. Looking at this MOSFET, all MOSFETs have the same pattern of arrangement, which is this first one is the gate, the center one is the drain, the last one is the source. So see what I mean by, before you check it, make sure you discharge any stored charge in the gate by using your finger like this. So let's check if this MOSFET is in a good condition. What did I say? First of all, looking at this symbol, we need to use the red probe and the source. This terminal is the source, while here is the drain. So we'll put our probe like this and like this to check, and let's see what our meter will give us. So the center one is the drain, while the third pin is the source. So watch what I'm doing. Yeah, so let me change it. I said that the black wire will be in the drain, while the red wire will be in the source. So that is what I'm doing. So this is the drain and this is the source. So we are getting a 0.521, which means we are getting a reading. So let me interchange it. As you can see, there is no reading to show you that this MOSFET is in a good condition. But if you get any reading, if you get any reading, whether you interchange the MOSFET, that means the MOSFET is bad. Okay, so in our next tutorial, I will show you how to use a MOSFET in a circuit, and also how to use a transistor in a circuit. So guys, if you like this video, please make sure you subscribe to our YouTube channel. Click the bell icon to be notified whenever we upload any tutorial on electronics, and also make sure you like and share this video. Thank you guys. Please keep on supporting me. Thanks.